My name is Cam Feenstra, and today I'm going to be walking you through how you can use ChatGPT to do all of your legal research for you. Just kidding. It's not quite there yet. There was actually this story about a month or two ago about some lawyers who used ChatGPT to do their research for them, and it actually made up a couple of cases that didn't exist, and the judge wasn't very happy with them, and they actually ended up getting fined for that. But it's not that far off. So what I am going to be talking about today is how you can build robust applications in domains where being correct really matters, using generative AI with the capabilities it has today and the limitations. Okay, so if you've worked at all with generative AI, particularly language models like ChatGPT, you've almost certainly heard the term hallucination or run into it yourself. And in general, this means the model is making something up or it's wrong. And so, for something like creative writing, this doesn't present quite as big of a challenge. And so there's lots of writing helping applications out there that work well. But there's plenty of domains where it's really not okay to just sort of have the model make something up. So the model hallucination presents a significant challenge when applying generative AI to problems where you really need to be correct. And so, ultimately, it's possible that this problem will eventually be solved on the model level. But what I'm going to be talking about today is more of a practitioner's guide to some approaches that you can use to build robust applications on top of generative AI models today, despite the limitations. And I'll be touching on both how to make the models themselves perform well, as well as how to architect your software system around these models so that you can, understand how well they're working, improve them gradually over time, and things like that. Okay, so I'll just spend a second talking a little bit more about the hallucination problem itself. So it's important to understand this is not a new problem. Ultimately, we're hearing a lot about it because people have started applying models like ChatGPT to all sorts of new domains. But there's actually this paper from 2018, Actively Avoiding Nonsense in Generative Models, that talks about the exact same problem. And one of the things that paper suggests is that a lot of the quote unquote nonsense or hallucinations, as they're mostly called today, comes from things that are out of distribution. So basically asking it for information that isn't in its training set. And when you think about it like that, really, it's even less of a new problem, because with any predictive model, it's not going to, almost any predictive model, it's not going to perform well on out of distribution samples. Even, something like a linear regression, this is a problem. So what's more difficult about generative models and language models in particular is that quantifying what's out of distribution is a lot more difficult. For example, you could say the exact same thing in two different ways, or if you're asking a model a question, there isn't a really good way to say write some code that can understand what information is needed to answer that question in order to understand if that information is in the distribution or the training set for the model. And then last thing to note is that this is not the only source of hallucination. There's also, I think if the model is fully making something up. That's more fitting for the word hallucination. But since this is a practitioner's guide, really we're worried about, is the model right or wrong? And so there's also other ways that it can be wrong outside of just making things up. For example, just because of how these models are trained based on tokens, it's an interesting quirk that they're very bad at spelling. So you can see in this example here, you ask it how many N's are in mustard. The answer is, of course, 0, but ChatGPT will tell you there are 2. So another thing that makes this a little bit of a difficult problem to track down is that particularly OpenAI models, but probably it's a similar thing with other providers as well. They're constantly improving. And so, if you find a method that makes the model hallucinate a lot, it won't necessarily continue to work over time. And it's also sort of interesting that as these models are OpenAI's models in particular have gotten a lot better at refusing to give you an answer when they don't have the information necessary to do it. But actually, this sort of RLHF, reinforcement learning from human feedback, which is one of the techniques that's used to create that behavior, can actually make the models worse in some dimensions. So there was this paper from about a month ago that tested GPT 3.5 and GPT 4 with some math questions versus results from a few months ago. And GPT 4 in particular went from getting it right almost all the time to almost never. And interestingly, during the same period, GPT 3.5 got better from only 7.4% correct to 87. Okay. Now, enough of talking about hallucination at a high level. So we want to build an application on top of a generative AI model, despite the fact that it can hallucinate. How can we do this? And so what makes it hard other than just the fact that the models hallucinate? So as I just mentioned, the models are constantly changing. If you own your own models, this isn't the case. But, if you use a third party, it is likely that the models are changing under the hood, which can mean that, you might deploy your software and it might be performing well, and then it might start suddenly not performing well. And even assuming the models stay the same, these models are inherently non-deterministic. So if you give it the exact same input twice, it generally won't give you the same output unless, for example, your provider is caching outputs for certain inputs or something like that. But yeah, in general, it won't give the same output for the same input twice in a row. But the good news is that we don't actually need to solve the problem of hallucination in order to build good software on top of these models, which is good because it's a hard problem and probably won't be solved anytime soon. But the fundamentals theory of software engineering is sometimes called all problems in computer science can be solved by another level of indirection. And so in that case, I'm just saying that to mean you don't have to solve these problems. All you have to do is make your application work, which is much easier. If you spend any time working with generative AI models, you've probably heard of prompt engineering, which is always necessary to building any sort of application on top of generative AI models. But it's actually not going to get you all the way there. So in this case, this example I have here, I added custom instructions to ChatGPT to tell it to only cite sources that it's 100% sure are accurate. And then I asked it to write me an essay about ducks. And it did a pretty good job. And it even gave me some sources, 2 of which were real, but one of them was not real. And it's plausible. The author exists. The author does write about ducks. But as far as I can tell, this specific paper does not exist. And so in order really to make these models work well, you need a little bit more than just telling them not to give you wrong information. One of the really useful tools to use in building applications on top of generative AI models that's relatively new is function calls, or in ChatGPT, they're called function calls. In other frameworks, there's similar functionality. I know for Llama, there's software that can do a similar thing for you, but this can significantly help in reducing the amount of prompting you need to do to actually get the result you're looking for. So in this example, I am asking ChatGPT to be an expert chef and to generate recipes for me. And I'm starting by just saying, give me the response in JSON format. And then I ask it for a recipe for tomato soup, and it actually does a good job. And, again, to note how these things are always changing, ChatGPT used to not do a very good job of actually giving you JSON or a specified format, even if you ask for it. But now it does actually give you valid JSON. But we can see here that I didn't specify anything about how I wanted the shape of the data to look. And so it basically just made one up, which, when you're building on top of this for an application, you'll want the data that it gives you to conform to a particular format. Now, if I could add a bunch more instructions saying, for example, give me preparation time in minutes, for each of the ingredients, give me the unit and the number or the quantity separately. I could say for each instruction, I want both the instruction and the amount of time it'll take. There's any number of things, but adding all of these via prompts is a little bit tedious. And I'll probably end up with a very long prompt. And at the end of the day, I don't really have any confidence that ChatGPT will always follow my instructions and give me the exact format I want. Now, with function calls, this is actually a pretty easy problem to solve. So now I've actually created a schema of exactly the shape of the data I want for a recipe. And if I use that and ask ChatGPT to give me a recipe and use that basically function call as the output, it will actually give me exactly the schema I'm looking for. So if you're building an application on top of this, this is really an excellent way to get it to really give you the shape of the data you're looking for, and is both more reliable and easier than specifying all this via prompting. Now, the next thing I'm going to talk about is about, as I mentioned earlier, a lot of hallucination comes from you asking the language model for information that it simply doesn't have, likely that it wasn't in its training set or in the context you provide to it as part of your prompt. Now, one of the best ways to fix that is to make sure that you provide the model with the information that it needs to answer your question. So, to give an example, if you want the model to tell you about a particular company, you could just ask it, but if information about that company isn't in its training set, it might just say that it can't fulfill the request, or it might give you wrong information. But if you instead gave it, information from news articles about the company, information from its website, information from, public filings, or any number of different sources, it's much more likely to give you the correct answer when you're looking for example, write me a brief summary of this company. Now, if you're providing the model with a lot of information, you quickly run into a new problem, which is that either, the information you want to provide is simply too big to fit in the context that the model can accept, or in the case when you're using a third-party API, often the cost is based on token usage. And so if you're sending a really large number of tokens with every request, it can get expensive very quickly. And so there are various different techniques you can use at that point to optimize the costs and basically how many tokens you're sending. One popular method is search. So particularly, there's a lot of, for example, chat with PDF apps that are going around that, you ask a question and it will basically take all the text in the PDF and give you an answer. And so for that use case, one of the popular techniques has been search. So essentially, rather than providing the entire text of the PDF to the model, you first embed either the sentences or passages of the PDF, and then you also embed the query, and you use that to filter down the sections of the document that you think are most likely to be relevant. And then you only provide those to the model rather than providing everything. This is going to be largely dependent on your use case, but another approach is to do a multi-step process. So, for example, if you want to summarize the financial position of a company, then let's say you want to ask a bunch of different questions about it. For example, is this company going bankrupt? What's the income of this company in the last several years, and possibly other things, rather than doing a bunch of different queries to answer each of those questions independently. You can take all of your financial documents, process each of them once, and ask the model to pull out specific fields you're looking for, and then shortly after, provide that condensed information to a model that actually makes the top level judgments you're interested in. Another really important thing, and again, like this slide is titled garbage in, garbage out. And so I want to stress again that, this is really not a new problem. It's very similar to the same problems that, there have always been with deploying AI-based applications. The main difference is just that a lot of, it's relevant to a lot more use cases now. The cleaner the data that you give to the model is, the better job it's going to do in actually giving you the right answer. And I'm going to give one example that we run into at Anzen of how, it's worth doing a lot of work to, before you ever give the data to the model, just in order to make sure that it has all the information it needs to answer the question you want it to. And then just sort of a practical tip is that ChatGPT is trained on a really large amount of Markdown. And so if you need sort of an intermediate format, Markdown is a very good choice because it does a very good job of understanding Markdown content. One example of something that we did at Anzen, just like one example of kind of doing a lot of work just to make sure that the information we provide to the LLM is really clean. So we process a lot of insurance applications, which look something like this. And if you just run OCR on this document, The results you get are actually not very good. There are, you can see the yes and no checkboxes. They're, under the corporate structure, there's basically, when directly translating this to text, it doesn't quite keep its integrity in a way that, someone, even a human reading the text, would be able to reconstruct what the application said from it. And so what we did is we first used a model called Layout LM to identify, within a particular insurance application, which sections are the questions and which are the answers. Obviously, this is not an insurance application, but this demonstrates the concept. And using that, as well as the OCR results, we were able to reconstruct a much more true to the original source representation or text representation of the insurance application, which the model did a much better job of understanding and giving us good answers to our questions based on. Now, another important tip is to really only use generative models for the things that only generative models can do. So, if, for example, you want to classify a particular piece of text as, one or more types of documents or something like that, fine-tuning smaller models with a data set you curate is extremely effective. And, for example, rather than giving, to use an example from Anzen, rather than giving the model any document and saying, tell me if this is an insurance application, and if it is, tell me all of this additional information about it. Right. We instead first have a classification model that was trained on a few thousand examples and has really good performance to determine if something is an insurance application. And then, given it is, then we provide it to the LLM, which gives it a much more constrained problem space and has had much better performance. And, it is important to note that fine-tuning models off-the-shelf models, you actually don't need as much data as you might think. You can get pretty good performance with just a few hundred examples. And, if you scale that up to a few thousand, you can start to get really excellent results. Speaking of one case at Anzen, we have something which essentially has 99.9% accuracy for classifying documents across a bunch of different types. Okay, now that's sort of a number of different tips for how to actually work with your large language model to get it to give you good results. But then the other side of it is, how do you architect your software system in order to, have a robust system that is based on these models? So, the number one thing to remember is that you always have to assume machine learning models are going to misbehave sometimes because, despite what you think, they will. And two of the important features that I'm going to talk a little bit more about are A, that you want to have some kind of feedback system built in, and B, is that you want to have a really granular continuous monitoring system so that you can understand how the performance is changing over time and intervene if needed. So the first really important feature that you want to include when you're building an AI-powered software system is some sort of feedback mechanism. And going back to one of my earlier slides, if oftentimes, especially if you're using third-party models like ChatGPT or one of Anthropic's models, the behavior can change over time. And even if you have a constant, or even if you're hosting your own model or something like that, the inputs, the data set that you're working with, or, the inputs you're giving to the model are probably also going to change over time. And so either way, it's really important to have some feedback system so that you understand as quickly as possible how if performance is going way downhill, or in general, just how the performance is changing over time. And it's really ideal if you build that feedback feature into your product. So for example, as a user, if I see something that's wrong, I can click a button and report that. And then ultimately, there's some sort of dashboard or something like that, where as an engineer, I can see all of the things that have been reported wrong, and ideally even alerting based on that, so that, if there's a big spike, you can intervene as quickly as possible. Now, if your software system is almost entirely this AI product and doesn't have a lot of features, you might be able to use usage numbers as some kind of rough proxy, but ideally you do have a first-class monitor feedback feature of some kind. Another thing to point out is that feedback data is actually really valuable, and if you implement it properly, you can use that for future training and fine-tuning of your models or new models, which creates sort of a feedback loop where, the models are improving, you get more feedback, or maybe, you start to get feedback about areas where maybe it improved overall, but there's certain areas it did worse in. And so you can sort of use this feedback mechanism as a way to continuously improve your product. Now, aside from monitoring feedback, you should also have really other robust monitoring systems around your product that go beyond feedback. So monitoring your feedback is great, but you should also be monitoring things like performance. You should be saving all the inputs and outputs that you send to your model. Ultimately, you should have the dashboards necessary to really understand how and if performance is changing over time, so that you can address it as quickly as possible, or potentially you can revert a change or whatever the case may be. Obviously that's a lot of information, but the conclusion is, ultimately things are moving very quickly, and, it's possible that everything I've said here in a year's time will be totally outdated. And quite frankly, even in the, couple of weeks since I made this presentation, I've had to change a lot of things. And I know that there's things that are missing because, all of this is moving incredibly quickly. And as I mentioned a few times, almost none of this is completely new. I think with language models specifically, there's certain things that have gotten harder, but ultimately, a lot of these are the same problems that have always existed with deploying ML models into production. Now, the models are going to keep getting better. That's one thing that's certain. Open source models are likely to start being kind of more production ready. At the moment, there's not really anything open source that meaningfully competes with OpenAI. But today, just throwing a bunch of information at ChatGPT or whatever, whatever model it is, isn't going to get you far for many problems, particularly ones where you really need the result to be correct. And so, creating a demo might be easy, but creating a real robust production system still requires a lot of effort. And, what I've said here are just a couple things that can potentially help with building these applications. All right, that's all I have. Thank you.